Hey everybody. Um, First things first, before I jump into today's lesson, I just wanted to quickly go back over the past couple of things that have been due that a lot of you have not turned into me yet, starting with the first thing that's on the screen, assignment from the 2 days that you were out last week. That's your solving systems by elimination. You guys have got to get that turned into me with all work shown if you want to have credit basically for those 2 days out of school. Right now, everybody is in there as absent, and until you turn in that work 100% completed, will those 2 days be taken off from my class as absent. Along with that, you were assigned on Friday, 5-4, solving special systems. You only had, I believe it was 6 questions on each side, so 12 questions total that you needed to get completed. So you need to get that turned in as soon as possible. I didn't want to throw a quiz at you today, but just know that tomorrow you will have a quiz over those 2 assignments up above, the solving systems by elimination and the solving the special systems. So make sure that you guys are prepared for that. So the outline for this week, Monday, which is today, we're going to be doing section 5.5. Tomorrow you'll have the quiz. You'll start the notes on 5.6. Wednesday you'll finish the notes if you didn't already, and then you'll do your homework on 5.6, plus make up anything else that you have not turned in. Remember, this is the new 9 weeks, and you guys need to stay on top of your grades. Thursday, that'll put us at our review for the Chapter 5 test, and make the test on Friday. So this chapter's closing pretty quickly here this week, and we will be moving on into Chapter 6 starting next week. So here we go. Today, we're going to be looking at how to graph and solve linear inequalities with 2 variables. And what's really cool about this this section is that we've basically already done everything that we're getting ready to do. It just throws like 1 or 2 extra little pieces at you. Just some vocab you'll be looking at, linear inequality, and then a solution of a linear inequality. So let's jump right into it, and here we go. A linear inequality is similar to a linear equation. That's everything that we've been doing up to this point. X plus y equals 2. 2x minus 5 is 3. You know, we've been doing things like that in the previous sections. Well, this time, instead of it having an equal sign, you're going to have an inequality symbol. Greater than, less than, greater than or equal to, less than or equal to. And then a solution of the linear inequality is any ordered pair that makes the inequality true. So when we dealt with just linear equations, we had one specific answer that answered that question. One specific x, one specific y. Well, with an inequality, you've got multiple different x-y combinations that will make that system true, or that inequality true. So let's jump straight into an example. This should look very familiar from section 1, except for now we got inequality symbols. Tell whether the ordered pair is a solution of the inequality. So notice that it gives you a coordinate point. -2, 4. So you got to remember what is x and what's y. It's always alphabetical order. You've got your x value here. You got your y value here. And just like the Glade commercial, what do we do when we're given an x and a y? We plug them into the equation in the right spots and see if it then will work. Okay, so our x is -2 and our y is 4. So we're going to put down 4 is less than 2 times my x value, which is -2, and then add that 1 on. So now we just have to simplify this and see if it holds true. 2 times -2, that is -4. We'll bring down that +1. I haven't done anything with it yet. Okay, nor have I done anything with that 4. All right, now let's simplify that right-hand side. We've got -4 plus 1. What is -4 plus 1? -3. So here is what we have. This reads 4 is less than negative 3. And is that the case? Is 4 less than negative 3? No. So is the solution, or is the ordered pair negative 2, 4 a solution of the inequality? Absolutely not. It's a no. Okay? Alrighty, let's look at the next example we have here. Your next one gives you the coordinate point 3, 1, and your inequality is y is greater than x minus 4. Okay? So same thing here. Let's plug this stuff in and let's see if this works. Alrighty, so x is my 3, 1 is my y. So we plug it in, we get 1 is greater than my x, which is 3 minus 4. Okay? That right-hand side, we've got 3 minus 4. We got to simplify that, which is negative 1. So this reads 1 is greater than negative 1. And is that true? Yes, this is a good one. So that coordinate point 3, 1 is a solution to this inequality. Alrighty, so we've got a couple more examples on this next slide here. And I want to go ahead and work through these just to make sure that everybody's got the hang of what you got to do here. So the first one, letter A, you've got the coordinate point 4, 5, and you got your inequality y is less than x plus 1. So let's get this set up. Y, which is 5, is that less than my x plus 1? Well, 4 plus 1 is 5, but is 5 less than 5? No. The only way that one would hold true is if that was a less than or equal to. But on this one, it's not. So that is not a solution to that inequality. Letter B, we've got the coordinate point 1, 1. So we're going to take each of the x and y values and plug them into the inequality. We get 1 is greater than 1 minus 7. So let's simplify that right-hand side and see if it works. 1 minus 7, hopefully all of you are saying negative 6. So is 1 greater than negative 6? Yes. So then the coordinate point 1, 1 is a solution to that inequality. Alrighty, so I'm going to skip that slide and we'll go straight to here. Now, so we started dealing and looking at how to find solutions by graphing to just a regular equation. Well, now with the inequalities, we have just a little bit more we've got to do. Okay, so I just started recording again. I have no idea what I left off on, but that's what makes this interesting and fun. So with this slide, it says we're going to be basically we're going to be graphing the inequalities. Okay, so before we were looking at how to graph just regular equations, and in order to graph a regular equation, what did we have to have? Okay, we always graphed them from what form? Slope-intercept. So we had the slope, we had the intercept. We used the intercept to plot the starting point. We ran the slope from that point. We made a solid line. Boom, we were done. But with these ones, there's just a little bit more work to them. Okay? So in general, the basic starting point of graphing a linear inequality is really the same. We put it in slope-intercept form. You graph the intercept, and you use the slope to graph the next few points of the line. But with the inequality, there's two different ways your line could be. It could be solid, like the red line on the graph, or it could be dashed, like the blue line on the graph. It's all dependent on what the symbol is, or what the inequality symbol is in the problem. So when you have a problem where you have less than or equal to and greater than or equal to. So you're looking at these parts right here. Alrighty? Because they are equal to, that is why the line is a solid. Now on the flip side of that, if you look at the blue part, notice that it's dashed. So that's when we use the inequality symbols of less than and your greater than. Notice they are not equal to. Okay, so that dashed line represents that boundary where there's no, like the solution cannot be on that line. That's just the boundary line that kind of borders and starts the answers. Okay, now what also has to happen with inequalities is we have to shade. And shading again is all based on whatever the symbol looks like. So if we're dealing with a symbol that is greater than or greater than equal to, most of the people can normally just say, oh, well, if it's greater than or greater than and equal to, I know then I need to shade on the top of the line. Okay, on the flip side of that, we have the less than or equal to, less than right there, or less than and equal to. If it is less than the line or less than the inequality equation, whatever is given, okay, you're going to shade below the line. So let's give this a shot. Here are the rules that are kind of spelled out for you step by step. So if you want to write these down, it should be on one of the slides on the handout for you as well. Your first step to graphing it, you got to make sure that it is in slope-intercept form. Plain and simple. The y has to be by itself every time before you start graphing. Number 2 is graph the boundary line. Okay, so that means plot that intercept, y-intercept specifically, on the y-axis. Use your slope to find the next point, and then you've got to draw your line. But first you need to know if it's going to be a solid or dashed, and it's all based on those symbols. So if you've got equal to in your symbol, it's a solid line. If you don't have the equals, then you've got a dashed line. And then last but not least, you have to shade. So if you have the symbol greater than or greater than equal to, you're going to shade above the line that you just plotted. If you have a symbol that's less than or less than equal to, you're going to shade below the line you just plotted. Now let's give this a try. Graph the solutions of the linear inequality. The linear inequality is y is less than or equal to 2x minus 3. So first things first, are we in slope-intercept form? Meaning, is y by itself? Yes, so this line or this inequality is ready to graph. We are going to start with this number right here. It's not with the x, so what does that mean? What is it? That is my y-intercept. So we go to the y-axis down to -3. Hopefully my stylus here will work out okay. Let me see if I can make it. There we go. Intercept at -3. The 2 in front of the x is my slope. Remember, we always have to have a fraction, so that means it's 2 over 1, or up 2, and then right 1. So if we go up 2, right 1, we got a point right there. Go up 2, right 1. We got a point right there. Okay, so hopefully those 3 dots there, you can see them clearly to know where our line's going to go. But now, before we go and connect those dots, we got to figure out what kind of line we're going to have. And that, my friends, is all based on that symbol. So I know I just covered it up, so let me uncover it. What symbol was that? That is a less than and equal to. The equal to tells me that I have a solid line.